Section 3.2 again, it's part B. And so again, we're still looking at slope. So the goal is I can describe types of slopes and can determine slope using the points formula. So types of slopes. So we've already kind of talked a little bit about these in the sense that we've worked with them. Now notice there's a happy face there in the corner, so you know that obviously this is something that you should be able to do on a test. So some of the types of the slope, obviously a positive slope. Okay, remember we read from left to right. Negative slope, again, when we read from left to right, it's going down. And then if we look at the last two, and these were two of the examples from yesterday, is a zero slope and an undefined slope. So what happens with a zero slope, remember that we're not moving our change in y. We don't have a change in y, so that's why it's 0 over a number. So we know that that will always equal 0. An undefined slope means that we have a vertical line. The change in y is any number we want, but our change in x, it's not changing, so it's 0. So remember, we can't divide by 0, so that's where we get the undefined. So every single vertical line will have an undefined slope. So we get those on vertical lines. And zero slope is always horizontal lines. Now those horizontal and vertical lines, later on when we're actually writing equations of lines, that's going to be important for us. Now I have here, remember, dividing by 0 is undefined, so that's why we get an undefined slope there. Okay, so star, it's an important thing. Slope, they use it as the letter M, a small m, not a big M. That means something else too. Okay, now why is it a little m? You could actually do some research, Google it, find out why do they use the lowercase m for slope. Okay, and see what you come up with. Now, formula for slope. Obviously, I don't want to draw a graph each time I want to do a slope. Maybe I do. All the questions we've done so far, the graph has been given and we just chose 2 points on it. Okay, but if the graph isn't given to us and we know something about it, it's a lot of work to graph something. So let's take a look at this point here and this point here. So say I've chosen these points. Okay, and if I create my delta x and here's my delta y. Really what's happening here is when I'm doing my change in x and my change in y, it has to do with these points. These points all have a coordinate. This point has a coordinate of an x and a y, and this also has a coordinate xy. Now, so that I don't get confused between the two, I'm going to use what we call subscripts, which are just little numbers. They're not exponents. So they're subscripts, sub meaning below. So, sorry, that shouldn't have been a 2. It should have been a 1. So I have a 1, an x1, and a y1. So that point has a coordinate of an x and a y. And if I look down at my second point, it also has a coordinate of an x or y, but it's my second point, so I'm going to call it x2 and subscript y2. Okay, so now we're looking at our changes between those. Now, if you remember when we were counting squares before, some of you were able to say, oh, I don't need to count them, I can just add or subtract. So when we're doing this and we're talking about the change of them, the slope, the m, is the change in y over the change in x. So my y's, I'm talking about my changes of my y's, y2 and y1. So really, change is going to be subtracting those two numbers. So the change in them, what's the difference between them? Because then that'll tell me how much space there is. And also the change in the axis. Okay, so delta y divided by delta x, delta meaning the change between. So it has created now this formula of m equals y2 minus y1 over x2 minus x1. Okay, so it looks kind of like a monster, but it's just the changes of the y's over the changes of the x's. So let's take a look now, and what I'm going to do is I'm actually going to group that formula because we're going to be using it a lot. Okay, so I've grouped it so we can always go back and get it. So here it says, find the slope of a line that goes through the points -3, -2, and point B of 2 and 4. Now, if you notice to the side, I do have an axis, and so what we're going to do is we're just going to quickly sketch where those points are. So point A, so we're going to go over approximately -3 and down -2. So that's roughly where our point A is located. And we know it's -3, -2. And our other point, we would go over 2, roughly up 4. So it's somewhere in here. Okay, so this is just a sketch so that we can see roughly what we're talking about. So what we're concerned about is the line that goes through those 2 points. Well, the way we've been doing it so far has been we would actually create this and we could calculate our delta y and our delta x. So if I look here, if I had to count the squares, I know that for my delta y, I would have to go up 2 and then another 4. So I know it should be 6. So how do I get 6? By using that formula for delta y. Well, let's take a look. Delta y would be, if we use that formula, y2 minus y1. I would take the 4 and I would subtract a -2. Watch out for the negatives. So when I do that, 4 minus a -2 is the same as 4 plus 2, so actually that's a 6. So I could do it with the numbers from the points, or if I did have it graphed, I could actually count them, and that's what we did here. Okay, so it gives you the same answer. Now, we can do the same thing for delta x. Delta x, well, I'm moving from this location on the x-axis to here, which would be a 3, and then another 2. So 3 and another 2 would be 5, and I think that one's going to disappear, so I better do it again. Would be 5. So will I get the same thing if I use the formula for delta x? Well, let's find out. Delta x is the second x2 minus x1. Now here it's important to make sure that I'm using the same x2. Okay, so if I look at my y2, I used the 4, so I said that this was y2, so that means this has to be x2. So that's one important thing. You have to use the same x2, y2. So you can't use one as starting with a y2 and the other one starting with an x1. So that those have to match. So what we end up here having is y2 is 2, and we're subtracting, a -3. So when I do that, I end up with a +5, which is what we ended up here when we counted the squares. So if I actually do it, then I can see that I get my slope equaling delta y over delta x, which equals 6/5. Okay, now let's actually formally do it with the slope formula, and this is what you would do. I wouldn't need to graph it. I would write down my formula. And to be on the safe side, I would have my points and I would label them underneath so that I would remember what I'm substituting it into the formula, that I'm doing it correctly. Okay, so if I say this is x, let's hold on, will be 1 a 2 and 1 a 1. And it doesn't really matter, but whatever one you choose, make sure you choose it each time. So I believe in our example, we chose that as being R2 and this one as R2. So this is the X1, Y1. Okay, so if I just put it underneath, then I'm not going to get confused about which one I chose to be my X2, X1. So our y's, so we would have 4 minus the negative 2 all over 2 minus the negative 3. Okay, again, what we would end up with is 4 plus 2, which is 6 over our 5. Okay. Now, what would happen if I chose it the other way around? Well, let's try that. Okay, so what I'm going to do is I'm just going to erase this for a second, and I'm going to then say, okay, well, what if I chose this as x2, y2, and this is x1, y1? Will I get the same answer? Well, let's try it. So our slope, again, is this formula. The more times you write it out, the more it's going to stay in your head. Okay, so y2 in this case is going to be negative 2 minus a 4. And the x2 is going to be negative 3 minus a 2. So are we going to get the same answer? Well, let's try. Negative 2 minus 4 is a negative 6. Oh, I don't know. Maybe we won't get the right one. And then the next one, negative 3 minus 2 is a negative 5. So if I'm dividing by two negatives, negative 6 divided by negative 5, that actually becomes a positive 6/5. And you can see that you get the same answer. So it doesn't matter which one you choose as your x2, y2, you'll get the same answer. Okay, so let's go and do lots of questions. So I have here, I guess just 2 questions here and then a worksheet and some work from the textbook. So let's try this again. So it says find the slope. So it doesn't matter which one I choose. So I'm going to say this is x2. Well, actually, I would probably say it's 1 to tell you the truth. So x1, y1, x2, y2. I'm going to copy down my formula. My formula is slope equals. And now all it is substituting into this formula. So when we substitute it in, we end up with 4 minus 2 over negative 5 minus 6, a matter of working with our numbers. So we end up with 2 over negative 11. And that's in lowest terms, so it's finished. If you notice, that's faster than having to graph everything. Again, I'm just going to label my numbers. And if you notice, I don't do any thought with that. I just make the first point x1, y1, and the second one x2, y2. It just makes my life easier. Again, I copy down my slope formula from my head. And it's a matter of substituting in. So I end up with 9, take away a negative 3. And on the bottom, I end up with negative 7, take away a negative 3. So I end up with 9 plus 3, so we have a 12 over 7 plus 3, so we're looking at 4, and we're not in lowest terms, so we have to divide there, so we end up with the number 3. Okay, stopping time. Have lots of mathematical pleasure tomorrow in class.